There are actual monsters out there somewhere in the world. We are unable to see them, but we are confident that they are still around. A black hole is unparalleled in terms of its size, power, and deadly potential. Nothing else compares. Planets and stars, really, anything that gets too close to a black hole is sucked in and consumed by it. Because they break every norm in the book, black holes are a source of great consternation for physicists. However, they continue to be the masters of the universe. They have moved to the forefront of the action. It is now common knowledge that they control the course of the universe's own evolutionary history. Black holes are among the most enigmatic phenomena that exist in our universe. Their gravitational pull is unrivaled in its strength. Nothing will be able to escape. They are capable of devouring entire galaxies. In the past, black holes were a common theme in science fiction. Now we have confirmation that they are indeed real. When I brought up black holes in conversation with my other PhD students, they would burst out laughing. They are fictitious animals, just like unicorns and dragons. This is what people mean when they talk about the giggle factor. People used to say things like, "Beam me up, Scotty," but now nobody laughs at these kinds of jokes. Because of this, we cannot classify them as works of science fiction. In spite of the fact that we have never set foot on one, there is sufficient evidence to suggest that they do exist. This picture might not look like much to you or I, but in the eyes of scientists, it is irrefutable evidence that black holes are real. This is an actual film, captured in real life, showing a black hole in the constellation Aquila consuming a star. Black holes are notoriously messy eaters. The red specks that you see are gas that is being expelled into space from the hole. This star will cease to exist sometime in the next million years as a result of the parasites eventually killing it and eating it alive. A black hole represents the point beyond which there is no turning back. It's the culmination of a star's journey. This is the ultimate state that matter can exist in. It is the last destination for energy. It is the culmination of the gravitational field. I mean, that pretty much sums it up. This is the very highest point on the scale. Even though they have the capability to destroy like nothing else in the universe, black holes also contribute to the formation of galaxies, which are an essential component of the great cosmic machine. This is despite the fact that black holes have the ability to destroy everything in their path. There is a school of thought among astronomers that suggests they could even be gates to other universes. Research into black holes has finally reached a point where it can be considered the golden age. They might be the answer to the age-old questions of how the universe came into existence, how it evolved over time, and ultimately how it came to an end. In certain respects, black holes are seen to be at the forefront of cutting-edge astronomical research. In addition, they are causing a shift in our understanding of the processes that underlie the formation of galaxies and, more generally, the operation of the universe. The force of gravity, which is one of the most potent forces in nature, is the source of their strength. Both physics and astronomy are subjects that I teach. And one of the most important lessons that we instill in our pupils is that the fundamental premise of gravity is that gravity stinks. Gravity is what allows humans to stand upright and what keeps our planet in its elliptical orbit around the sun. However, the gravity in a black hole is so extreme and powerful that it draws in anything that is in the surrounding area. Even light from distant stars might be distorted by it. When the light reaches too close to the black hole, it is consumed by the phenomenon. Take into account the following, just like a waterfall. A black hole can be thought of as a waterfall. The river that is moving toward the falls represents gravity, while the kayak represents a ray of light. There is less of a flow of water further upstream from the waterfall. The kayaker can escape by paddling in the opposite direction of the current. However, as they draw nearer to the waterfall, the current becomes more intense, and the kayaker finds it increasingly difficult to escape. There is a striking resemblance between the edge of the waterfall and the edge of a black hole. No matter how strong the kayaker is, he is going to capsize. There is no way around it. The situation is exactly the same in space. The gravity of a black hole ramps up to a terrifying level as one approaches it, making it one of the most perilous objects in the universe. That they can get away with eating a little less. Because of this, black holes appear to be completely black. Please also see, a black hole can be thought of as a cosmic cockroach hotel. Everything appears to be in order. There does not appear to be anything incorrect. Planets, stars, and even entire solar systems will be destroyed if they come too close to the black hole. Also, you shouldn't consider this to be some far-off occurrence. There are black holes running amok right here in our own cosmic neighborhood. We now know that there are nomads traveling across the Milky Way galaxy, vagabonds traveling throughout the galaxy, where black holes might appear right behind you and possibly suck you up without so much as a burp. If one gets too close, be sure to keep an eye out for it. If a black hole were to reach our solar system, it would destroy everything and everyone in it. It doesn't matter what kind of black hole it is, if it can make its way through our solar system, it will have a stronger gravitational force than the Sun does on all of the planets. As a direct consequence of this, it will entirely throw off the gravitational equilibrium of the solar system. The gravity of the black hole would yank planets off of their orbits and cause them to collide with one another. It is nothing short of a cataclysmic failure. It's the equivalent of a bull fighting in a china shop. If it gets close enough to a planet, like Jupiter, for example, it might be able to drag the moons of that planet away from it. As it raced across the solar system, it would throw planets to the left, right, and everywhere in between, leaving a path of destruction in its wake. If a black hole were to get closer to Earth, the immense amount of gravitational energy it would produce would rip asteroids out of their orbits and send them hurtling toward Earth. It would be a firestorm across the entire surface of the planet. That moment would mark the beginning of the end. The atmosphere would be the first thing it would consume, followed by the planet itself. The elimination of an entire solar system is of no consequence to a black hole. But it's not just a large, empty, space-hogging piece of space, there's more to it than that. That item has an astonishingly high weight. If you want to get an idea of how big and thick a black hole is, think about how dense the Earth is. Now begin to crush it, and continue crushing it until it is packed so densely that the atoms themselves break apart as a result of the pressure. The density of a black hole is equal to the density of the Earth when it is compressed down to a width of just 2 inches. It would weigh the same as Earth and have the same gravitational attraction, despite being only the size of a golf ball. What could possibly cause something to be so compact, but so thick and potent? The formation of black holes is not possible since there are no external forces, such as enormous pistons, in the cosmos. Therefore, gravity is the one and only factor that can play a role in the formation of genuine black holes in the universe. There is just one location in all of space and time where such a high level of gravity may be found. In addition, it can be found inside the most massive stars. A supernova is the name given to the enormous explosion that occurs when big stars that are 10 times the mass of our Sun pass away as a result of being crushed by gravity. Some stars, though, are significantly brighter. These supermassive stars are 100 times more massive than our Sun and have 100 times the gravitational pull. When one of these massive stars expires, it sets off the most powerful explosion in the universe. A supernova, this is the beginning of the formation of a black hole. There are an infinite number of stars in this universe. Some people have a peaceful passing at the end of their lives. Others are consumed by dazzling fire blasts as they perish. And some of them are responsible for the formation of black holes. When a star, particularly a supermassive star with a mass 100 times that of the Sun, reaches the end of its life, the fuel in its core eventually runs out. Once there is nothing left to bind it together, the center will fall apart and become a black hole. When anything like this occurs, the immense gravitational force that is created at the core of supermassive stars becomes uncontrollable. DY Canis Majoris is a star that is on its way out. It extends for more than 1 billion kilometers in every direction. It, like every other star, is a gigantic nuclear fusion reactor that sends energy into space. Concurrently, the star's tremendous gravity exerts an inward crushing force. Since the beginning of time, fusion and gravity have been at odds with one another. At that point, the standoff will be over. Fusion will come to a stop when the star runs out of fuel. Wins. Within 1 millisecond, the core undergoes a dramatic reduction in size, giving rise to the formation of a new, smaller black hole. It quickly starts devouring what is left of the star it was attached to. The temperature rises to excruciating heights as more and more matter falls into the black hole. And there are magnetic forces as well as frictional forces, and what's going on immediately above the surface of the black hole is a witch's brew and a nightmare all rolled into one. The newly formed black hole in the galaxy's center is continuing to consume the body of the star. The gas is consumed by it at such a rapid rate that it causes it to choke and cough, releasing tremendous beams of energy. They eat their way out of the star, which is essentially how it works. It happens in milliseconds. This takes place before the remainder of the star is aware that its core has disappeared. As a direct consequence of this, the star expires before it ever reaches the ground. The star has finally disintegrated. It releases 100 times more energy in 1 second than our sun will create in its entirety over the course of its entire existence. The only things that have survived are a new black hole and 2 energy jets that are moving at the speed of light through space. These explosions of gamma rays are referred to as gamma ray bursts. The events are known for their high levels of excitement. Gamma ray bursts are only surpassed by the Big Bang itself in terms of the amount of raw energy and power that they produce. This places them in second place. The vast majority of them merely survive for a few seconds at most. They will also destroy everything that stands in their way. They are so potent that a gamma ray burst occurring in the region of our galaxy that is close to our solar system has the potential to completely melt the planet. Fortunately, the majority of gamma ray bursts occur in galaxies other than our own. However, they do provide us with some useful information regarding black holes and the operation of our universe. What we were witnessing each time a gamma ray burst went off was, in essence, a black hole giving birth to its first cry. Astronomers are able to determine the daily production rate of black holes by keeping track of the number of gamma ray bursts that occur. In 2004, NASA sent the SWIFT probe out into space to look for gamma ray bursts throughout the universe. The countdown begins: 5, 4, 3, 2, and 1. Now that we have it, we can. We also have the launch of NASA's SWIFT spacecraft, which is on a mission to explore and understand gamma ray bursts throughout the universe. This is another exciting development. The gamma ray burst that SWIFT found is the most powerful one found to date. SWIFT reveals that a new black hole has formed on the opposite side of the cosmos. You can just take a glance at a small portion of what's available. Despite this, it is able to identify at least one gamma ray burst every single day. This revelation shook the basic basis upon which the field of astronomy was built. Black holes were once thought to be unfindable, much like unicorns. However, recent research has proven that this is not the case. It is now generally accepted among astronomers that the night sky is home to billions of black holes. When we look outside of our galaxy and at other galaxies, we can see that the cosmos is filled with extremely powerful black holes. It's one thing to find out there are black holes in the universe. Finding out how they function is a very new ballgame altogether. Visiting one is the only way to determine whether or not it is effective. To get close enough to it, you would need to travel a significant distance through the emptiness of space in a spacecraft. After that, you'd have to descend into the depths of the black hole. There might be a location where the rules of reality don't apply and time seems to stop moving. There are billions and billions of black holes throughout the universe. With the help of our telescopes and satellites, we are able to locate them. But we have no notion of what they look like when they're up close and personal. Even if it won't be for a very long time, scientists are already making preparations for a trip to a black hole. A journey with only one way out to the most perilous spot in the world. When physicists first learned about the concept of black holes, they were shaken with fear. They intended to get rid of them because it appears that the physical principles we know of become invalid at the moment a person enters a black hole. Time pauses. Gravity takes control and reaches an unending state. This is turning into a terrible nightmare. It should come as no surprise that we can't get any humans close to a black hole. However, what about a machine? It is possible for a robotic probe to relay data back just before it goes over the edge of the cliff. The boundary of a black hole is known as the event horizon. It's the end of time and space, at least in our little corner of the cosmos. Because it delineates the boundary between two distinct parts of space, the event horizon is given the name event horizon. It's not just a matter of the surface itself. It's possible that if you're falling through it, you won't even see it, but as soon as you step inside, it'll be too late. As you get closer to the event horizon, the gravitational pull becomes stronger, and unusual phenomena start to take place. When you fall into a black hole feet first, you may not know how close your feet are getting to the edge of the void until it is too late. As a result, the gravitational attraction that they experience is amplified. Because your head is not quite as close, the gravitational force that it experiences from the Earth is diminished. In a nutshell, you end up becoming more stretched out as a result of this. Your feet are being pulled much harder than your head, and you are being tugged like taffy between two strong people. The draw on your feet is significantly stronger than the pull on your head. You are going through a process known as spaghettification, in which you are essentially being changed into a long, thin tube of pasta as you get thinner and thinner and thinner as you go closer and closer and closer. This happens as you get. Our robotic probe would be stretched to its breaking point by gravity, and then it would be torn apart by gravity. Suppose the probe has sufficient strength to survive and carry on its mission. Everything begins to spiral out of control as the event horizon draws closer. Time stands still. A halt is put to gravity. It is so intense that it halts the passage of time. We have this notion that the passing of time is an unending process. On the other hand, time appears to stand still within a black hole in some ways. This may make no sense at all, yet that is how the system operates. The proof can be found in the calculations. In point of fact, it is intertwined with the very structure of the cosmos itself. When observed from a greater distance, the robot probe gives the impression of moving more slowly as it gets closer to the black hole. After that, it looks like everything has stopped completely. It's possible that the whole process will only take a few seconds. To those on the outside, it seems as though time has stopped and you are falling at a more measured pace. In actuality, it is impossible to see an object traveling the full distance through the event horizon. Because its clock is an infinite number of times slower than yours, it will literally freeze up on the surface. In point of fact, the investigation has not in the least been halted. It continues on its course and passes through the event horizon. If the cameras on the probe are aimed in the opposite direction, toward the opening of the black hole, it will be able to observe the phenomenon of light being sucked into the hole. If it points the camera in front of it, at first all it will see is darkness, but as it gets closer to the center of the black hole, it will see the strangest spot in the entire universe. The tremendous force of the black hole's gravity draws everything in its vicinity to a single point that is unimaginably tiny at its center. It is known in the scientific community as the singularity. There are some things about the interior of a black hole that simply cannot be explained. Because of the extremely high densities, the previously established physical rules are no longer valid. Singularities are places of infinite gravity that are at the same location but exist nowhere else in space or time. That is beyond ridiculous in every way. A singularity might be seen as an alternative method of expressing the sentiment "I'm not sure." It is a slang expression that means "I have no idea." Even in this day and age, researchers are unable to provide a conclusive response to the question, what is a black hole? It is a little uncomfortable to consider the possibility that there are things in the world that defy the laws of physics. There must be larger laws that black holes employ, that black holes obey, and that we just don't comprehend yet. Currently, our knowledge of these laws is limited. The one thing that we are certain of is that black holes are created when stars end their lives. And the majority are rather modest in size, measuring approximately 20 kilometers across. But recently, researchers have found that the size of some black holes can vary greatly from that of others. They are referred to as supermassive black holes, and their magnitude is comparable to that of our solar system as a whole. And one of these creatures resides at the center of our very own galaxy. Our solar system is located in the Milky Way galaxy. It is made up of billions of stars, including our Sun, that rotate around a mystery location in the middle. Children ask, if the Moon circles around the Earth and the Earth revolves around the Sun, what rotates around the Sun? That's a good question. Astronomers have the same question. Perhaps there was something going on at the center of the Milky Way, such as a black hole. But, because we can't see black holes, all they could do was look for telltale indicators. They looked at the center of the galaxy with infrared instruments and discovered a densely packed swarm of millions of stars. They couldn't see what was in the center. One team has spent 15 years seeking hints. The huge Keck telescope, perched high above the clouds on Mauna Kea in Hawaii, has the potential to view right through to the center of the Milky Way. The region that we must explore to confirm the presence of a black hole is exceedingly small. It's just like looking for a needle in a haystack, but we know exactly where the needle is. Andrea has spent endless nights looking for it. Gez has spent countless hours monitoring the core of the galaxy for evidence of a black hole. To carry out this experiment, one needs to be able to see and place stars very close to the center of the galaxy with high precision. And this is the same as me in Los Angeles looking at you in New York and watching you move your finger like this. At the same time, when the Keck kicks into action, a laser beam detects minuscule disturbances in the atmosphere that would distort the image. The motors then adjust the massive 30-foot mirror to compensate. The image is clear enough to track the stars at our galaxy's core. Over the last 15 years, Gez has taken thousands of images. And what they reveal is remarkable. The stars at the galaxy's core are traveling at millions of kilometers per hour. The core of the galaxy is a highly harsh environment. Stars move at significantly quicker speeds than anywhere else in our galaxy. And that, my friends, is clearly the signpost of the black hole. They seem like small planets rushing around an invisible sun. But they're not planets. They are celebrities. It takes a lot of gravitational power to swing big stars around in such quick, tight orbits. A supermassive black hole is the only thing in the universe with that much pull. Observing these things shows the presence of a 4-million times the mass of our Sun black hole at the center of our galaxy. It's a major breakthrough. Our entire galaxy, including our own solar system, rotates around a gigantic black hole. However, the Milky Way isn't the only galaxy with a black hole at its center. Most galaxies in the cosmos contain supermassive black holes. Our nearest neighbor, the Andromeda Galaxy, is our closest galaxy. It spins around a supermassive black hole 140 million times the size of our Sun. Other galaxies, like M87, have black holes weighing up to 20 billion suns. What causes black holes to grow so massive, and what do they do at the centers of galaxies? To get answers, we must travel roughly 14 billion years back to the beginning of the universe. The universe was filled with clouds of gas from the Big Bang at the time. The gas was thick enough in some regions to support the birth of millions of stars. Most of these new stars are already supermassive. They burned hot and quickly before exploding, leaving a path of black holes in their wake. The early cosmos was a chaotic and crazy world, with vast chunks of mass collapsing catastrophically and forming black holes. In fact, the early cosmos may have been filled with nascent black holes. Many of them were drawn together by gravity. They combined everywhere in the early universe, forming larger and larger black holes. Each black hole developed over hundreds of millions of years, producing stronger gravity and sucking in more and more gas. New stars were created from the gas, producing the earliest galaxies. But the black hole kept taking in gas until it couldn't anymore, unleashing the universe's most powerful flamethrower. A young galaxy is a huge cluster of stars created from gas clouds. A young, supermassive black hole at the heart of the new galaxy is devouring gas and rising in size. When a galaxy is very young and still forming, a supermassive black hole is forming at its center, and gas is still pouring into it and making the galaxy. Things are getting incredibly hotter towards the black hole's center. That material is getting heated. The gas is rushing into the black hole. But it overflows, and there isn't enough storage for all that hot gas. It has no choice but to depart. It's propelled into space by massive, powerful jets of energy. Each of these jets is 20 times wider than our solar system and shoots clear through the cosmos. A quasar has been ignited by a supermassive black hole. Quasars are the most dazzling objects in the cosmos. They're so intense that they can outshine an entire galaxy. This is a true image of a quasar in the galaxy M87, 50 million light-years away. Quasars discharge tremendous volumes of gas from their surroundings every minute, the equivalent of 10 Earths. When a gas is heated, it expands and blows outward. It's similar to wind, but on a far larger scale. You also get a black hole wind, which is gas blowing out from the black hole. Black holes suck gas in. Quasars obliterated it. But eventually, there is no more gas to generate stars, and the galaxy stops growing. As a result, we assumed that the eventual size of a galaxy is determined by the black hole at its center. The two are inexorably intertwined. With no more gas remaining to feed on, the quasar jets shrivel and die. What remains is a supermassive black hole at the heart of the galaxy, surrounded by a swarm of young stars, just as our Milky Way was when it was young. We were most likely a quasar early in the Milky Way's existence, when it was still a newborn galaxy. Probably every huge galaxy was once a quasar when it was young. But we're old enough now that the cosmos has quieted down. Scientists are now searching for quasars, which are the key to discovering new black holes and understanding how they work. The Chandra Optical Observatory is a satellite telescope that can detect the intense X-rays quasars throw off. It's found in tens of thousands. These magnificent photographs depict quasars of various forms and sizes blasting into space. Each one depicts a new galaxy with a new black hole at its center. As their galaxy evolves and takes on its final form, these quasars will eventually calm down. I guess the universe is comparable to people. Busy when young, quieter and more relaxed as they get older. We now know that supermassive black holes and the quasars they spawn control galaxies. Holes are crucial to understanding how galaxies originate. They're vital to understanding how they change throughout time. As a result, rather than being obscura, they are important to our knowledge of our galaxies and universe. To find out more about black holes is to have a good look at one. And since an up-close visit is, well, not a smart idea, astronomers are trying to discover a way to take a photo of the supermassive black hole at the center of our very own galaxy. They'll need a telescope the size of the Earth to obtain it. At the center of the Milky Way sits a supermassive black hole. It's shrouded by a thick cluster of stars that ring the galaxy's nucleus. But we hope to be able to view it soon. Believing comes from seeing. It would be fantastic if we could get up close and personal with the event horizon of the black hole at the center of the Milky Way galaxy. That is the Holy Grail. The center of most galaxies contains a supermassive black hole. We only know they exist because the stars in their neighborhood are being dragged in at millions of kilometers per hour. However, there may still be a way to image the event horizon, which is the very edge of the black hole itself. Shep Dollmann and his crew are aiming to obtain a photograph that displays the shape of its structure. In other words, we're really hunting for the shadow, or the silhouette, of the black hole within this cloud of gas that's spinning around it. This technique that we're utilizing, I believe, is our best opportunity for actually seeing a portion of the universe that has hitherto been utterly invisible to us. Optical telescopes cannot directly observe the black hole. The incandescent, superheated gas surrounding the black hole puts out radio waves that can be used to generate an image. These transmissions from space are picked up by large radio telescopes. The antenna will move in azimuth and height only. This one, located in Boston at the MIT Observatory, is more than 100 feet wide. It's big enough to detect very feeble radio signals from the black hole in our own galaxy, some 25,000 light-years away. However, it is not quite large enough to capture an image. We need to reproduce these telescopes and distribute them over the planet to create a virtual telescope as vast as the Earth itself. From Hawaii to Chile to Africa, Dolman's telescope can be discovered. We will link up radio telescopes throughout the globe, from Hawaii to Chile to Africa. When the network is fully connected, they will have a virtual dish 10,000 kilometers across with 500 times the power of a single telescope. They hope it will be powerful enough to picture the event horizon of the Milky Way's supermassive black hole. They're already picking up signals from our galaxy's dark core. When we saw the first detection, I just looked at the computer screen and thought to myself, my God, we've done it. We've actually seen something so small that it must have come from right around the event horizon. The signals are still too weak to produce a complete picture, but Dolman thinks that when more telescopes come online over the next 5 years, the photos will improve. The outline of the black hole itself should emerge. But even if a picture can't be compared to viewing it for oneself, we may have the technology in the distant future to enter and travel through a black hole, and potentially even survive the journey. Then we might finally know what is at the heart of a black hole. Some scientists believe that black holes may be exploited as a form of portal, allowing mankind to travel throughout the universe. The mathematics appears to show that when you go through a black hole, you don't simply perish, you fall right through a wormhole, which is a doorway, a shortcut through space and time. Perhaps we could just rocket throughout the cosmos through a cosmic subway system that we call a black hole. If black holes are shortcuts through space and time, it may make one of science fiction's coolest notions a reality. Time travel is theoretically conceivable, but not very practical. The energy source, the material required to keep a wormhole's throat open, is something so unusual that it cannot be created in a laboratory. But, if you could, you might be able to use the power of black holes to travel back in time. Perhaps our forebears have already mastered this technology. So, if someone knocks on your door and claims to be your great-great-great-great-granddaughter, don't slam it. These holes might possibly be doorways to other universes. There could even be a Big Bang on the other side of a black hole. Maybe the matter gets blown out the other side through a white hole. Isn't that akin to the Big Bang? If the Big Bang is simply the opposite of a black hole, this could be how our universe came to be. If you look at the calculations for a black hole and plug in the properties of the cosmos, such as its mass and size, bingo. You discover that our universe solves the equations for a black hole. That is to say, it is possible that we are currently located inside of an event horizon. Maybe we are currently living inside of a black hole. Every single black hole has the potential to serve as the womb from which an entirely new universe emerges. If what you've heard is true, then it's possible that there are billions of universes in the cosmos, each with its own collection of stars, planets, and forms of life. No matter what else we learn in the future, we already know that there are black holes everywhere. They are much larger and play a much more significant role in the development of the cosmos than we could have ever guessed. The discovery that there are black holes in every part of the universe has had a profound impact on our understanding of the universe that is visible to us through telescopes and the universe that is important to us. In the past, many individuals held the misconception that the physics behind black holes was far too fantastic to ever be real. They have now moved to the forefront of the stage. It is now common knowledge that they control the course of the universe's own evolutionary history. When I was younger, black holes were most commonly found in works of science fiction. It was something that had to be avoided at all costs. Your spaceship makes evasive maneuvers in an attempt to evade them before it is sucked in. However, as more time has passed, we have come to realize that black holes play not just one significant role, but a multitude of significant roles throughout the universe. It is not an exaggeration to argue that there would be no such thing as humanity if there were no such thing as black holes. Black holes are directly responsible for our very existence. The narrative has not come to a close just yet, either. There is a significant amount of information that has yet to be uncovered regarding the enigmatic entities known as black holes, which are also referred to as the rulers of the universe.